morning, friends. After the discussion of the definition of the wave and also the importance of the wave, we discuss what is the wave. The motion of a disturbance in medium or vacuum, that is known as the wave. That means whatever the disturbance produced in a medium or vacuum, this disturbance is propagated in the medium or in the vacuum. So whatever the pattern is formed, that is known as the wave. Right? Whatever the importance of the wave in our daily life, we also discuss. Now, today in our this lecture, now what is the classification of the wave, or which type of the waves are possible in our daily life? So here, now the waves can be classified in three categories. First is the mechanical wave. Second is non-mechanical wave, that is known as the electromagnetic waves. And third is the matter wave. Okay, in physics, we are related with the medium and also the vacuum, and also the tiny particles like as the electron, proton and neutron, corresponding to the motion of these particles or the motion of a particle or disturbance in medium and vacuum. We classify the waves in three categories. First is the mechanical wave. The definition of the mechanical wave is that the waves which requires an elastic medium for their propagation. To move the disturbance the medium is required. Such waves are known as the mechanical wave. Again, the waves which requires the elastic medium for their propagation, such waves are known as the mechanical waves. Now remember, which type of the waves we consider in the mechanical wave? What are the waves produced in a water? As we throw a stone, so disturbance produced on the surface of the water. These waves are mechanical waves. In a string is tied by the one end with a rigid support and other is for a hand, as we produce the disturbance. So disturbance produced in the wave is propagated in a string. So this type of the waves in a string are also the mechanical wave. Now the sound wave, we know that in vacuum the sound wave cannot propagate or cannot move. To propagate the sound wave, the air medium is required. Therefore, the sound wave is also the mechanical wave. Now, during the earthquake, what are the waves are generated? So, seismic wave. This seismic wave are propagated on the surface of the earth. Two types of the waves are produced in during the earthquake. The seismic wave propagate along the surface of the earth. Thus, for the seismic wave, for the propagation, the earth medium is required. So in short, the string, waves in a string, spring wave produced in a spring, water waves produced in a water, sound waves and seismic waves are the example of mechanical wave. Again, what is the mechanical wave? The waves which requires a elastic medium for their propagation. Such waves are known as the mechanical wave. Example of the mechanical waves are the waves in a string, spring waves, water waves, sound waves, and also the seismic waves. Etc. waves are known as the mechanical wave. Next is second type of the wave is non-mechanical wave, that is also known as the electromagnetic waves. We learned about the electromagnetic wave in 12th standard. Okay, in chapter 8. Okay. Now listen, what is the definition of the non-mechanical wave? In mechanical wave, elastic medium is required. Here, no any medium is required. The waves which not require any medium for their propagation is known as the non-mechanical waves. Again, the definition of the non-mechanical wave is that the waves which not require any medium for their propagation. Such waves are known as non-mechanical waves. They are also known as the electromagnetic waves. So in short, non-mechanical waves are also known as the electromagnetic wave. Now what is the electromagnetic wave? For electromagnetic waves, suppose there is the direction of propagation of electromagnetic waves. So here, the electric field and magnetic field are propagate in perpendicular direction to each other. That means the electric field vector are oscillate along the y direction. This figure is only for your knowledge. While the magnetic field component or the magnetic field vector oscillate perpendicular to the oscillation of electric field. Like this way. And the oscillation of both electric and magnetic field also perpendicular to the direction of propagation. Here the wave is propagating or the moving in this direction with velocity v along the x direction. So wave is propagating in this direction, electric field component oscillate like to this way vertical, while the magnetic field component is oscillate like to this way. Electric field vertically upward direction, magnetic field this way, and direction of propagation of wave is perpendicular to the both E and B. So here the magnetic field is in this direction, electric field is in this direction, and direction of propagation is this. So the propagation of this type of the wave, no medium is required. We know that the light coming from the sun, between the some region between the earth and sun, there is the no medium. In spite of no medium, we get the light from the sun. That means the light waves radiated by the sun reaches to us. For the propagation of this type of the wave, medium is required, not required. Whether medium is present or not present, that is not affected for the motion of such wave. Therefore, all light waves, like as the radio waves, X-rays, gamma rays, infrared, ultraviolet rays, all light waves are the example of non-mechanical wave. Again, in non-mechanical wave, the waves which not require any medium for their propagation, such wave is known as the non-mechanical wave. They are also known as the electromagnetic waves. Now, in electromagnetic waves, electric and magnetic fields oscillate perpendicular to each other and also perpendicular to the direction of propagation. So this sentence is explained by this figure. Figure is not required only for your understanding. What are the examples of non-mechanical or the electromagnetic waves? All light waves, like this, the radio waves, X-rays, gamma rays, infrared rays, UV rays, ultraviolet rays, all light waves are the non-mechanical waves. Okay. All types of the electromagnetic waves have the same speed in vacuum, and its value C is equal to 2.99 into 10 raised to 8 meter per second, and which is known as the velocity of light in vacuum. So in short, all the electromagnetic waves have the speed is same in vacuum, and its value is 2.99 into 10 raised to 8 meter per second. Generally, we consider as the 3 into 10 raised to 8 meter per second. That is the velocity of light in vacuum. So in short, the light wave is also an electromagnetic waves. We learned about this in 12th standard in chapter 8, electromagnetic waves. Okay. So there is the mechanical wave, there is non-mechanical wave. For mechanical wave, the medium is required for their propagation, and while non-mechanical wave, no any medium is required for the propagation of the wave. Now next is the new types of the wave, that is known as the meta wave. Meta wave, that means when a fundamental particle of mass m moves with a velocity v, its motion can be described by a wave of wavelength lambda is equal to h upon mv. Lambda is equal to h upon mv. Here the h is the Planck's constant. Its value is 6.625 × 10⁻34 joule into second, and such waves are known as the meta wave. Actually, that is the equation of the de Broglie wavelength. De Broglie wavelength. You also learned about the de Broglie's concept about the particle and wave nature, right? In chapter 12. Okay. Now here the lambda is the h upon mv. Mv is the momentum. There is also written as the h upon p. P is the momentum of a particle. Momentum, that means the mass into velocity. As we know, the mass and speed of a particle moving in either medium or the vacuum, we can find out the wave nature of this particle corresponding to its motion. Right? Again, when a fundamental particle of mass m moves with a velocity v, its motion can be described by a wave of wavelength lambda is equal to h upon mv is equal to h upon p, where the h is the Planck's constant. Its value is 6.625 into 10⁻34 joule into second, and such waves are known as the meta wave. These meta waves are also known as the de Broglie waves. Meta waves represent the motion of a fundamental particle like electron, proton and neutron, atoms and also the molecules. They interact and shows their effect similar to the effect of the mechanical and non-mechanical wave. So what is the importance of the meta wave? Why the study of the meta wave is required? For that purpose, the electron, proton and neutron are very small particles having the small mass. When we describe the motion of such type of the fundamental particle like as the electron, proton and neutron, so the motion of this type of the fundamental particle is not represented by our ordinary method. For that purpose, here we require the de Broglie's wavelength, and the motion of such wave represents the same effect of the mechanical and non-mechanical waves. To represent the motion of a fundamental particle like as the electron, proton and neutron, what is the wave is represented by such fundamental particle, that is known as the meta wave. So the waves are classified in three categories: mechanical, non-mechanical and meta wave. In mechanical wave, the elastic medium is required for the propagation of their wave. For non-mechanical wave, no any medium is required for the propagation of the wave. While the meta wave, when the fundamental particle of mass m and velocity v moves with velocity v, its motion can be represented by the wave of wavelength lambda is equal to h upon m. And this wave is known as the meta wave, and meta wave is also known as the de Broglie waves. Okay friends, after the discussion of the classification of the wave, now what is the propagation of longitudinal wave in elastic medium, and also explain the motion of disturbance in a train while the shunting it. That means when the engine of a train is connected with its coaches, So we have the experience as the engine connected with the first coil. At the time, the slightly push is given to the coaches by the engine. So the effect of this slightly push is transferred to the one coach to the second, second to the third, and so on, turn by turn. Right? Actually, that is the longitudinal waves are produced in each coach. So we are going to explain this thing. The propagation of longitudinal waves in series connection of the elastic spring, and also explain the motion of disturbance in a tent while shunting it. For that purpose, here consider the series connection of three elastic springs. Consider the series connection of elastic springs as shown in the figure. Okay. When the free end of this connection is slightly pushed and then released. Slightly pushed and then released. So what's happened? The first spring, the length of the first spring is changes. That means the expand and contract. It means the oscillation is start in a first spring. So here, when the free end of this connection is pulled slightly and then released, the disturbance is produced in the first spring as its length changes from its normal condition. It expands and contracts periodically, means the first spring starts oscillating about its mean position. Again, consider the series connection of the three springs horizontally. As the free end of this connection is slightly pulled and released. So what's happened? The disturbance is produced in a first spring. So as a result, the length of the first spring is expand and contract from its normal condition. Right? That means the first spring start the oscillation about their mean position. Now, because of elastic properties of the medium or the spring, so what's happened? The disturbance making the second spring oscillating. Due to the disturbance produced in the first spring, the first spring is start the oscillation. Here, the second spring is also connected with the first spring. Therefore, this disturbance also make the second spring oscillating, and then the third spring, and then so on, turn by turn. Because of the elastic property of the medium, such disturbance making the second spring oscillating, then third spring, and so on. Thus, the disturbance is moving from one end to the another end, and which is the propagation of longitudinal wave in the elastic medium. Okay. Such waves are mechanical waves. That means the longitudinal waves are mechanical waves because an elastic medium is required for their propagation. Longitudinal wave is required, the medium. Therefore, there is the mechanical wave. The longitudinal waves, because the particle of the medium oscillate parallel to the direction of the wave. This wave is known as the longitudinal wave because the particle of the medium oscillate parallel to the direction of propagation of the wave. Here the disturbance is produced here. This disturbance is propagated in this direction along its length. Therefore, that is known as the longitudinal wave. Very easy answer the question. And here the same phenomena take place in when the engine of a train is connected with its coaches or the bogies. Again, explain the propagation of a longitudinal wave in the series connection of the spring. Consider the series connection of the elastic spring as shown in the figure. The free end of this connection is pulled slightly and then released. So what's happened? The disturbance is produced in the first spring as its length changes from its normal condition. So this end is pulled and then released. So disturbance is produced in spring. As a result, its length is increased and decreased. That means the expand and contract. The first spring starts oscillating about its mean position. Because of elastic properties of the medium, the such disturbance is making the second spring oscillating this way. And then third spring starts oscillating, and so on. Thus the disturbance is moving from one end to the another end, which is the propagation of longitudinal wave in elastic medium. Right? Such waves are known as the mechanical wave because an elastic medium is required for their propagation. These waves are known as longitudinal wave because the particle of the medium oscillate oscillate parallel to the direction of propagation. Here the direction of propagation is this. Particle of the spring are also oscillate parallel to the direction of propagation. Therefore, these waves are known as longitudinal waves. Okay. Now, in case of a train, consider a stationary train whose coaches are coupled successively by elastic spring. We know that the coaches of the train successively connected by the elastic spring, like this. When the engine of a train is connected with the first body, is connected with the first body or the first points. During the shunting of a train, that means while the connecting an engine with the first points, it starts the vibrating. In turns, make the second coils vibrating, then third and fourth and so on. So what's happened? When the engine is connected with the first points, so here all the coaches are successively connected with a spring with each other. So when the engine is connected to the first coil, it applies slightly jerk or the push. So as a result, what's happened? The first coil starts oscillating about their mean position. Now all the coaches are connected with the elastic medium like a spring. Therefore, this disturbance is transferred to the second coil. Second coil starts oscillating about their mean position. This disturbance again transferred to the next coils. So this way, turn by turn, each and every coaches start vibrating. Right? The first coil is found to be affecting all the coaches turn by turn. Such motion of the disturbance is also called the propagation of waves in the medium of a train. So first the disturbance is take place due to the connection of or the shunting of an engine with a first coil. So this disturbance is transferred to the one by one coaches. That means this disturbance is transferred from one end to the another end. And hence there is the propagation of longitudinal wave in elastic medium. Right? And this wave is also the mechanical and longitudinal wave produced in each coaches. So there is also the example of a train. What is the mechanical? What is the longitudinal wave are propagated in case of a train? Okay. Sound wave is also a longitudinal wave because during the propagation of a sound wave in a medium, so the particle of the a medium are oscillate along the direction of propagation of a wave. So sound wave is also the example of a longitudinal wave. During the propagation of a sound wave in a medium, the same phenomena take place. But in case of a medium, here the condensation and rarefaction is take place. We discuss later this portion.